we have discussed about electric charge and electricity. So we know electricity is the flow of charges, right? So what happens um, in some substances, electric charges can flow easily, while in others they cannot. On the basis of that, substances are divided into two categories. One is conductors and the other one is insulators. The substances through which electric charge can flow, they are termed as conductors. And as you know that the flow of electric charge is nothing but electricity. So you can say the substances through which electricity can flow, those substances are termed as conductors. And what are those substances? What are our conductors? These are our metals. As you know, all the metals like copper, silver, aluminium, they are all conductors. In fact, the metal alloys like nichrome, manganese, which we use for making heating elements of electrical appliances, they are also conductors. But yes, their electrical conductivity is less than that of pure metals. Carbon, that's a non-metal, but in the form of graphite, that is also a conductor, that also allow electricity to flow through it. Our body, human body, that is also a good conductor. And the next category, that is of insulators, in these are those substances through which electric charge cannot flow. So the substances through which electricity cannot flow are termed as insulators. And the examples of insulators are glass, rubber, paper, in fact, cotton, dry air. These are all insulators because they do not allow electric charge to flow through them. But yes, in case of charged insulators, whenever our insulators are charged, like as you studied that glass rod, when it's rubbed with a cloth, it accrues some charge. In fact, when you rub a plastic scale with your hair, then it will that plastic scale attract some pieces of paper. It means that a plastic scale has accrued some charge. So it you can say we can say so it means that the substances, the insulators, when they are rubbed, they accrue some charge, but those charges do not flow. Those charges are bound to them, they do not move away. That is why those substances are termed as insulators, because electric charges do not flow there. Okay, so why is the difference of this behavior? What is the reason for this difference in their behavior? Okay, so you know that all the conductors, if we talk about metals, they all have some electrons. And in the case of metals, in the case of conductors, what happens? um, Electrons which are present there, they are loosely held by the nucleus of their atoms. And because they are loosely held, that is why those electrons are termed as free electrons. And when the electrons are free, they are loosely held, so those electrons can move from one atom to another atom throughout the conductor. So it's actually the presence of free electrons in a substance that makes it a conductor. So in a conductor, what happens? Free electrons are present. That is why substance becomes conductor. That is why those electrons flow. That is why electric current flow there. Okay, and what happens in case of insulators? Electrons are also present there, but those electrons are strongly held by the nucleus. And since there are no free electrons, electrons are strongly held, there are no free electrons which can move. That is why an insulator doesn't allow electric charge, doesn't allow electricity to flow through it. So it's actually the presence of free electrons in a substance that makes it a conductor. Okay, now in a conductor, there are free electrons present, right? When these free electrons move in a specified direction, in a particular direction, what are electrons? Electrons are negatively charged particles. So when these negatively charged particles flow in a conductor, they constitute electric current. So current is the flow of charge per unit time, or you can say the flow of electrons in per unit time, because actually electrons are flowing, negatively charged particles are flowing because these are free. Okay, current is denoted by the symbol I. Okay, now the magnitude of current in a conductor is the amount of charge that passes through a conductor in per unit time or in 1 second. So if suppose if a charge, as you know, the charge unit of charge is coulombs, so it's represented by charge is represented by q. Okay, and time is represented by t. So we will get that current is equal to charge by time. Current is represented by I, charge is represented by q, time is represented by t. So you will get I is equal to q by t. So if q coulombs of charge flows through a conductor in time t seconds, then the magnitude of current would be I. Okay, that would be a magnitude of current would be given by I is equal to q by t. Now the SI unit of current is ampere, and this ampere is denoted by the letter A, capital A. Okay, there are other smaller units of current also. One is milliampere, that is represented by symbol MA, and the other one is microampere, represented by the symbol mu A. Now 1 micro milliampere is equal to 10 raised power minus 3 ampere. It means almost it is 1 by thousandth of amperes. Okay, and 1 microampere is equal to 10 raised power minus 6 amperes. These are very much small quantities of current, smaller units of current. Okay, now current is measured by an instrument that is called ammeter. Okay, now if I ask you to define 1 ampere of current, because the unit of current is ampere, if I ask you to define 1 ampere of current, what would be the value of 1 ampere? How can we define 1 ampere? So when you are going to define 1 ampere, that is equal to when 1 coulomb of charge flows through a conductor in 1 second. Whenever 1 coulomb of charge flows through a conductor in 1 second, it is said to be 1 ampere. Okay, now this is our ammeter, and it measures the current flowing in a conductor. So whenever you want to check, you want to measure the amount of current flowing in a circuit, you can connect ammeter in that circuit and you will get the quantity of current. Okay, you will get the measure of current. Ammeter is shown by the symbol A, and one end of this is a wire, and this is connected to the positive end, and this wire is connected to the negative end. Okay, now ammeter has low resistance. See, this is a new word for you, resistance. We will discuss about it later. Okay, next, ammeter is always connected in series. Now what is the connection in series? That means when you are connecting ammeter end to end in a line. See, I'm showing here a circuit diagram where you are having a bulb, battery, key, and this is our ammeter. And see, this ammeter is connected in a line with this bulb. The end of bulb is connected to the end of ammeter. That is the connection in series, and ammeter is always connected in series. This was all about the current